Hi, and welcome to Scientific Notation Part 2, another power session with Mama L. Today you're going to be learning about adding and subtracting with scientific notation as well as multiplying and dividing. So with adding and subtracting, there are different rules than multiplying and dividing. With adding and subtracting, our labels must match. So where are our labels, right? Well, our labels are our exponents, 10 to the 4th, 10 to the 5th, 10 to the 3rd, and so on. So which ones here could we add or subtract? Well, let me get my pointer out here. And let's look at this one first, okay? We've got 4.139 times 10 to the 4th and 1.6 times 10 to the 5th. Could those be added as they are? No, unfortunately not, because they don't match their labels. What about the next one? 6.5 times 10 to the 3rd minus 3.0 times 10 to the 3rd. Yes, our labels match. We have 10 to the 3rd each time, so we could go ahead and subtract those as they are. The last one, 10 to the 12th, 10 to the 13th. No, unfortunately, wouldn't work. Sad cupcake right there. All right, and then once you've done their problem, make sure that it's back in scientific notation format when you're done. So let's take a look at this problem here. It doesn't matter whether you pick 10 to the 4th or 10 to the 5th. One of them needs to match. So let's just pick 10 to the 4th and stick with it. 4.139 times 10 to the 4th. And then 1.6 times 10 to the 5th. Well, we don't want it to be 5, right? We want our labels to match. So I'm going to take away 1 from there to get it to be 10 to the 4th. Yay, matching labels, right? So if I do that, I've got to add 1 spot of power to get that 1.6 to kind of be balanced out. Well, 1 spot of power makes it 16, right? 16.000 if you want to line up your decimals. Now we're able to add them up. 20.139 times 10 to the 4th, because our labels matched. So we're not quite done yet. Remember, our reminder is that we have to have our number back in scientific notation form. So we're going to go ahead and scoot this decimal to the left 1 spot, taking a spot of power, but we're going to give a spot of power back over here. So it ends up being 10 to the 5th anyway. So if we actually had picked 10 to the 5th to begin with, we wouldn't have to change it. We wouldn't have to do this extra step to get it back to scientific notation format. With this next one, 12 and 13 labels don't match. So let's make them both 13, okay? We're going to say 2.11 times 10 to the 12th. Well, we don't want that to be the case. We want this to be 10 to the 13th. So we're going to add a spot of power to that, take a spot of power over here. So our decimal is actually going to be right there, okay? Then we're taking away 5.23. So I'm going to scoot my 5 right there because I need my decimals to line up nice and neatly. 5.23 times 10 to the 13th. Okay. Now this is a little tricky because you have this number, and I'm going to rewrite it over here. 0.211 minus a bigger number, 5.23. I'll put a 0 there just so everything is lined up. And you can plug that into your calculator if you want to, which I'll do right now. And I get a negative number, which makes sense. Something small minus something bigger, right? Negative 5.019. And that's already in scientific notation format. It's between 1 and 10. Okay? Now it's a negative, but that's all right. So then we have multiplying and dividing. A little bit of difference, but the good thing is it's a little bit easier. So quick background is when you multiply with a matching base, you just have to add your exponents. So if I had 2 to the 5th, that's the same thing as 2 times itself, 5 times. If I multiply that times 2 to the 4th, that's just a bunch of 2's, right? That's 2 to the 9th. See, you just get to add up all the 2's that you have. 8 to the 7th times 8 to the 2nd, well, I've got 9 8's being multiplied. 10 to the 3rd times 10 to the 2nd, you'll notice I did that. It looks familiar, right, with our 10's, 10 to the 5th. So we're going to be doing that with our exponents in a little bit. The opposite is true when you divide with the matching base. You just get to subtract your exponents. Again, if I had 2 to the 5th, and I divided by 2 to the 4th, what you end up doing is you just cancel out those 2's, right? And you have 1 2 left over on the top. So 5 is 1 bigger than 4. So this ends up being just 2 to the 1st power. 8 to the 7th divided by 8 to the 2nd is 8 to the 5th. And 10 to the 3rd divided by 10 to the 2nd is 10 to the 1st. So we're going to apply that when we multiply and divide. When we multiply, we'll get to add them. When we divide them, we'll get to subtract our exponents. All right, so labels don't need to match when you multiply and divide. So let's try out these problems right here. All right, get those calculators out and get them handy. You don't need to worry about changing your labels. So it's one last step. It's really nice. Just multiply the front of your scientific notation. So I have to flip my calculator here. 4.139 times 1.6. And I got 6.6224 times 10, and I get to just add up all my 10s. I've got 9 of them. That's it. When I'm dividing, I'm going to do 6.5 divided by 3.0. Notice these are the same numbers I used for the addition and subtraction, but I just changed the problems to multiplication and division. I get 2.16 repeating, and then times 10, well, 3 minus 3 is nothing, times 10 to the 0 power. And that's in scientific notation form, so I can keep it that way. Last but not least, I'm going to go ahead and use this one to multiply. So 2.11, 5.23, I got 11.0353. And look at all these 10s I have, times 10 to the 25th. But we're not quite done yet. Look, I'm not snug as a bug in a rug. I'm going to scoot that decimal over, taking a spot of power there, so I'm going to give that spot of power to my exponent. 1.10353 times 10 to the 26th power. And that's it. Thanks for coming today, and hopefully you'll get some use out of some of my other videos. Have a great day. Bye.